These are the two examples from the site, and we're going to factorise both of these quadratic expressions. Now, the first thing I'm going to do is determine whether or not they're easily factorised, even though the question says they are. And for this first one, the coefficients of the quadratic are that a equal 2, b equal -1, and c equal -6. And we're going to evaluate the expression b squared minus 4ac, which is called the discriminant, and see if it comes out to be a perfect square. And if it is, we can easily factorise it. So this is going to be equal to -1 squared minus 4 times a, which is 2, times c, which is -6. This is 1 minus, and we have -12 times 4, which is -48, and this comes to 49. So this is a perfect square, so we can use this method I'm going to demonstrate to factorise this quadratic very easily. Now the usual thing is we have to find two numbers that multiply to give the value equal to a times c, which is 2 times -6, which is -12, and these two numbers, which multiply to give -12, have to add up to b equaling -1. And if we have a little bit of a think about it, we can come up with those two values, and they'll be -4 and 3, positive 3. So if I multiply these two together, I end up with -12, and if I add them together, I end up with -1. Now the technique, we put our brackets here, we have two factors, vinculum, and the coefficient of the x squared is 2. So I'm going to write 2x over 2. So we have the coefficient of x squared appearing in 3 places. The two numbers that I've found, I just write in -4 plus 3. And with this technique, the denominator will always divide into one of the factors or both of the factors of the numerator if this quadratic is factorisable by this technique. And we see here that the 2 will divide into the 2x minus 4, giving me x minus 2, and the remaining factor 2x plus 3. So nice and simple. We do a similar thing with this quadratic here. We have that a equals 6, b equal -11, and c equal 3. Evaluate the discriminant again, and that will be equal to -11 squared minus 4 times 6 times 3, which is 121, minus 72, which is also 49. So this is easily factorised by this technique. AC is equal to 6 times 3, which is 18, and b equals -11. And the two numbers which multiply to give 18 and add up to equal -11 are -9 and -2. -9 times -2 is 18, and -9 minus 2 is -11. So once again, set up my brackets. This time the coefficient of x squared is 6, so 6x over 6. Notice that a appears 3 times again. The two values I have are -9 and -2, but this time you see that 6 will not divide evenly into either of the two factors in the top. But what I'm going to do, and you don't need to make a new line for this, but I'll do that here, is I'm going to change it into 3 times 2. Now 3 will divide into the first bracket, so I have 2x minus 3, and 2 will divide into the second bracket, so I'll have 3x minus 1. And so my quadratics are factorised very nicely.
Hello my baby, hello my honey, hello my ragtime gal. Send me a kiss, my one. Baby, my heart's on fire. If you refuse me, honey, you lose me. Then you'll be left alone. Oh baby, telephone and tell me I'm your own.